Hello and welcome to section 1.5b, combination of functions. And in this section we're going to talk about composite functions. And composite functions are basically one function inside of another function. And so when we look at this, we're saying that basically when we say this is f of g of x, meaning that if we have a function like f of x equals x squared and say g of x equals x plus 2, then what would happen is for f of g of x, what that basically means is that we are going to take the g of x and replace all the x's in the f of x equation and with what g of x is. So really I could write this as this is equivalent to f of x plus 2 because that's what g of x is, and now that would mean that in f of x I'm going to replace all the x's with x plus 2, so the final answer for this one could be written like x plus 2 squared. So composite functions is putting one function inside of another. Now if I would have asked you for g of f of x, how does that change? Well, that means that this is f of x inside g of x. So that means I'm putting x squared. So I might write it like this, that x squared is being replaced for f of x because that's what I chose f of x to be. And now I'm going to put all my x squareds into the original, into g of x, which would get me something like this. So it's a little bit different functions when you put one inside the other. For f of g of x and g of f of x, you get different solutions. But that's what composite functions are all about. And so now we're going to practice this just a little bit, same idea as what we were just talking about, that f of x is x plus 2 and g of x is 4 minus x squared if I want f of g of x and g of f of x. So that's what I'm going to work on. We'll start with f of g of x, and just like before, I'm going to write this as f of, well, g of x is really 4 minus x squared, so that means that I'm going to replace all my x's in f of x with 4 minus x squared. So that gives me 4 minus x squared plus 2, because this was my x value in my function up there, and since I was replacing all my x's with 4 minus x squared, that's what I get. Now I could combine like terms to make things a little bit easier, and so the final solution for this will end up being negative x squared plus 6. And that's what I would be looking for as the composite function for f of g of x. Well, for g of f of x, as you saw in the last example that I gave you, this is going to reverse the process a little bit. So now I'm going to write this as g of, well, what is f of x? X plus 2. So I'm going to replace all the x's in g of x with x plus 2. And so I get 4 minus x plus 2 squared, and now I've got to multiply out x plus 2 squared. And so remember that I'll just kind of do a little side note over here, that x plus 2 squared is x plus 2 times x plus 2, which if using the distributive property, I'm going to say x times x plus 2. So this first x times this whole parentheses, and then my positive 2 in the first set of parentheses times the second whole parentheses. And so by doing that, if I distribute the x to both terms, I get x squared plus 2x, and then another 2x plus 4 when I distribute this guy. And so then my final answer for that part is x squared plus 4x plus 4. So that's the multiplication of x plus 2 squared. And so my final answer for this, well, not my final answer, but my close to final answer is 4 minus, now be careful because x plus 2 squared was in parentheses, meaning I'm subtracting it, so I've got to rewrite this whole thing with the parentheses to make sure that I distribute this negative to everybody. So 4 minus x squared minus 4x minus 4. So when this is all said and done, I will subtract the 4's from each other, and my final answer for this problem will be negative x squared minus 4x, which is a little bit different than the problem before when we did f of g of x to g of f of x. So then they're asking me to find the domain of this composite function down here. And the domain of the composite function is just the domain when I simplify this. So I will do what I just did in my previous example. F of g of x will be written as f of, well, g of x is the square root of 9 minus x squared. And so wherever I see an x in f of x, I'm going to replace it with 9 minus the square root of 9 minus x squared. So I have x squared, which would be the square root of 9 minus x squared, minus 9. Well, a little simplification of this, remember squaring and square rooting cancel each other out. They're inverse operations of one another, so they will cancel each other out. So I'm really left with 9 minus x squared minus 9. And so to cancel out, to subtract the 9's from each other, which would give me 0, which means my final answer for this of my composite function for f of g of x is negative x squared. So then they're asking us for the domain of this composite function, and so then we have to think of the domain of negative x squared. And if you were to graph negative x squared, you may remember that it is an upside down parabola that looks like this. And the domain for a parabola is negative infinity to positive infinity. So basically we could say this, or all reals, for the domain of negative x squared. So this is the solution right here, is that our domain is everything. So this concludes our video notes for section 1.5b. If you have any questions, please come to class prepared to ask them.